flat sheet of steel weighs almost nothing on its own, yet it becomes strong enough to survive a rollover. An engine block starts as molten aluminum poured into a mold, yet it ends up precise enough to run for 200,000 miles without failing. Thousands of parts arrive from hundreds of different suppliers, yet somehow they all meet at the exact same second, on the exact same line. A truck this size can weigh over 2.5 tons, yet a robot can lower its entire body onto the frame with less clearance than the width of a coin. Panels built months apart in different production runs somehow come out matching in color so precisely that no customer would ever guess they weren't painted side by side. And a vehicle made of thousands of individual moving parts somehow rolls off the line every 53 seconds, ready to drive, without a single mismatched piece. That shouldn't be possible at this scale. So how does a truck as massive and complex as the Ford F-150 get built, tested, and shipped out the door at that pace, day after day, without a single mismatched part? Let's step inside and find out. Every F-150 starts life as something you'd never guess. A giant roll of aluminum, thinner than a soda can, sitting in a warehouse. Within a few hours, that same soft metal will be shaped into panels tough enough to survive a hailstorm at highway speed. The process begins with coils of high-strength aluminum alloy, chosen specifically because it's lighter than the steel older trucks used to use, but engineered to resist dents just as well. These coils are uncoiled, flattened, and cut into blanks. Flat sheets sized for each specific body panel: hood, doors, bedsides, fenders. Each blank is fed into a stamping press that can generate over 4,000 tons of force in a single strike. Enough pressure to shape a hood in under 2 seconds. The press doesn't hit just once. The panel moves through 5 separate stages, each one refining the curve a little further, until what started as a flat sheet has the exact contour of a truck fender, accurate to less than a millimeter. While the outer body panels are being stamped, a separate line is building the frame, the backbone of the truck. Steel rails are roll-formed into a boxed shape, then robotic welders fuse over 500 individual welds into place, each one taking a fraction of a second and landing in the exact same spot on every single frame that passes through. The stamped panels and the welded frame don't meet yet. Instead, robotic arms lift the body panels into position and begin an automated weld sequence, fusing hundreds of connection points with lasers and resistance welders that never get tired and never miss a spot. Here's the part that sounds impossible. This entire body shop runs almost completely without a single human hand touching the metal. Over 95% of the welding is done by robots working in a tightly choreographed sequence, and if just one robot is off by even a couple of millimeters, an entire batch of frames can be thrown out. By the end of this stage, what started as a soft roll of aluminum and a stack of steel coil is now a fully welded, rigid truck body, ready to move into paint. A raw welded body doesn't stay bare metal for long. That factory-fresh truck color is deceptively simple looking, but it's actually the result of a process so precise, a single speck of dust in the wrong place can force an entire panel to be repainted. Before any color goes on, the bare metal body is dipped completely, fully submerged, into a series of chemical baths that clean, treat, and coat the metal to prevent rust from the inside out. The body is lowered into an electrocoat bath, where an electrical charge pulls a protective primer layer onto every single surface, including spots a paint gun could never reach. Inside door cavities, underneath the frame rails, deep in the seams. From there, the body moves into a sealed, filtered paint booth, where the air itself is controlled down to the smallest airborne particle. Because even a piece of dust smaller than a grain of sand can ruin a glossy finish. Robotic arms apply a base color coat, followed by a clear coat, each layer measured in microns. Thinner than a human hair, but precise enough that panels built months apart still match in color exactly. The truck then passes through a bake oven, curing the paint at controlled temperatures for close to an hour, hardening it into a finish designed to survive years of sun, salt, and gravel. Paint booths like this are so tightly controlled for contamination that workers entering them wear specialized suits, similar to what you'd see in a semiconductor cleanroom. Not because the paint is dangerous, but because a single hair or fiber could show up as a visible flaw on a $60,000 truck. What comes out the other end is a fully painted, glossy truck body, but it still doesn't have an engine, a single wire, or a seat installed. That all happens next. While the body was being painted, a completely different part of the factory has been building the heart of the truck. An F-150's engine begins as molten aluminum poured into a mold. Yet by the time it's finished, its internal tolerances are measured in thousandths of an inch, tighter than the width of a human hair. Engine blocks are cast from aluminum alloy, poured into sand or die molds that create the rough shape of the block, complete with the cavities where pistons will eventually move thousands of times per minute. Once cooled, the rough casting is machined on computer-controlled equipment that drills, bores, and finishes the cylinder walls to an almost mirror-smooth surface. Pistons, crankshafts, and camshafts are installed by a combination of robotic arms and trained technicians, torquing bolts to an exact specification every single time. Because an engine bolt tightened even slightly wrong can cause a failure thousands of miles down the road. Meanwhile, on the main assembly line, the painted body is finally married to the frame. This is one of the most dramatic moments on the entire line. The body is lowered down onto the chassis, and hundreds of bolts are driven into place within seconds by synchronized robotic arms working in perfect coordination. From there, the truck moves down the line piece by piece, wiring harnesses threaded through the body, dashboards installed, seats bolted in, tires mounted, and the engine finally dropped into place and connected. Every single F-150 on the line might be a different configuration, different engine, different trim, different color, yet the line never stops because the exact right parts are delivered to the exact right station at the exact right second. This is called just-in-time delivery, and it's arguably more impressive than the robots. Parts from hundreds of different suppliers, some located hundreds of miles away, are timed to arrive within minutes of when they're needed, meaning the factory doesn't even store most of its parts. They're built, shipped, and installed almost as fast as they're made. Once the final bolt is tightened and the last wire connected, the truck rolls off the line as a complete vehicle for the very first time. But it still has to prove itself before it's allowed to leave. Before any F-150 reaches a dealership, it has to survive one final gauntlet. A brand new truck rolling off the line looks finished, but it hasn't actually been driven yet, and it won't leave the factory until it has been. Every completed truck is routed to an in-plant test area before shipping, where it undergoes a series of checks no customer ever sees. First, the truck is driven onto rollers that simulate real road speeds, allowing technicians to check the transmission, brakes, and alignment without ever leaving the building. Sensors log dozens of readings in seconds, comparing them against exact target values. Next, the truck passes through a water test booth, where high-pressure jets simulate a heavy rainstorm from every angle, checking for leaks around doors, windows, and seams. Any moisture detected inside sends the truck back for rework before it's allowed to continue. Finally, a portion of trucks are pulled at random for a deeper inspection. Panel gaps measured with precision tools, paint checked under bright inspection lighting, and interior fit and finish reviewed by hand. Panel gaps between body parts, like the space between the hood and the fender, are checked down to fractions of a millimeter. If a gap is even slightly uneven, the truck doesn't ship. On a vehicle built from thousands of individual parts, that level of consistency is what separates a functional truck from a truck that feels genuinely well-built. Once a truck passes every test, it's cleared for shipping, loaded onto a multi-level rail car or truck carrier, and sent out to dealerships across the country. That's how a roll of soft aluminum, a puddle of molten metal, and thousands of parts from hundreds of suppliers become a fully assembled Ford F-150. Precision, timing, and engineering. Most drivers never think about every time they turn the key.